Mic check. Hi, my name is CD Suhas. This is my Info 7390 take-home final on teaching a data science concept. My concept is storytelling with data, interactive dashboards, and perception-based design. This notebook is structured like a tutorial. It mixes theory, code, interactive plots, and small exercises. So I'm using Google Colab, so I keep the setup minimal. The only required install here is a Plotly. One reason I chose Plotly is because it supports interaction and works well inside Colab. So here are the core libraries I used. I used Pandas and NumPy for transformation and summary metrics. I used Matplot library and Seaborn for a couple of quick static distribution charts. And then we have a Plotly for the main interactive storytelling visuals. I also set the Plotly render to collapse so charts display reliably. So now for the dataset. I'm using Gapminder, which is bundled directly inside the Plotly library. This avoids a common collab problem like a broken dataset URL or GitHub rate limits. The dataset includes country, continent, year, life expectancy, GDP per capita, and population. Then for the columns and shape, this is a quick cell that is ran for the sanity check, which has the dataset shape and columns. In storytelling, this matters because we need to confirm the dataset contains the narrative ingredients like a time axis and a grouping variable and and measurable outcomes. For the column, for the missing values, I check the missingness. Even though Gapminder is clean, teaching good habits matters. So for the real life dashboards, so that's why the real life dashboards fail, because when they're built on unstable data. For feature engineering, now I add a few the right features, like total GDP as GDP per capita times population, and log of GDP per capita because GDP spans orders of magnitude, and then population in millions for readability. These features improve interpretability and make later visuals more meaningful. Interpretability. And now for the setup. The short question is, as countries get wealthier, do people live longer, and is progress evenly shared? This is the hook and defines what success looks like. We want interpretable visuals and actionable insights. So now I compute a KPI snapshot for the latest year. How many countries, global average life expectancy, median GDP per capita, and total population covered. This is the dashboard mindset. So we start with the high level indicators before deep diving. And now for the KPI table. Output. And then we have the histogram that shows the distribution of life expectancy. From a perception point of view, distributions are best shown with histograms with density plots, because we want the shape, spread, skew, and where most countries fail. And now, this box plot compares life expectancy by continent. Box plot shows quickly show median, spread, and outliers without clutter. This becomes our baseline for the uneven progress theme. And now for the interactive relationship. This is a core interactive visual where we have the life expectancy versus GDP per capita. The bubble size as population and color as continent animated across years, as you can see. For the chart choice, scatter is ideal for relationships between two continuous variables. And then we have the pre-attentive cues. Position encodes the relationship, color separates continents, and size gives context about population weight. And now we use a log scale on GDP because the range is huge. Without it, low-income countries compress into a corner. For the action on screen, we now press play on the animation for a few seconds, hover over a country. You can see So now we have a line chart trend view where we have the average life expectancy by continent over time. The line charts are best for time series because humans read slope and direction easily. This helps us compare improvement rates across continents. Now for the this plot shows how strongly well. One second, I'm sorry. Now we have a GDP trend by continent log view where we have the median GDP per capita by continent over time. Again, we're using a log scale. Now we can compare whether wealth growth aligns with the life expectancy trends. And for the correlation by year, I compute correlation each year between log GDP per capita and life expectancy. This is to teach a critical principle that relationships are not fixed, but they evolve. Now we have another plot which shows the strongly wealth and longevity move together over time. The correlation is not causation, but it's useful for summarizing patterns and motivating deeper investigation. To prevent a single year conclusion, I summarize by continent and plot life expectancy over time, because this helps answer which continents improved fastest and whether progress is uneven. Now I have a correlation where I computed the log GDP per capita, and this reinforces a key teaching point. As I said, that correlation is not causation, but it's useful for tracking how strongly two variables move together across time. So to summarize, this tutorial teaches how to engineer dashboards that support human decision making through a perception-based design and a structured story. The deliverables include the Collab notebook, tutorial documentation, and the pedagogical report. Thank you.